Parallel aggregation is something we haven't talked about much, but it turns out to be pretty simple. It starts by having an understanding of how we compute an individual aggregate across multiple nodes. And this is usually done with a scheme called hierarchical aggregation. And the way this works is that for each aggregation function, we need to know a sort of global local decomposition of that function. So there's some aggregation that we do locally, and then finally at the end, there's some aggregation that we do for the global final aggregate. So for example, for sum, if we have some data on one node and some data on a second node, the first node sums its data, the second node sums its data, and they can each take their local sums and put them together with a global sum to get the total sum. Okay, so sum is really just a sum of partial sums. Count, on the other hand, each node does a local count, and then you take the counts from the two nodes and you sum those together to get the total count. So for count, the global function is sum, whereas the local function is count. Now for average, of course, we're going to do the sums separately from the counts. For min, you can figure out what it would be, and for max, you can figure out what it would be. But in general, for aggregates, we're going to have local decompositions, local aggregates, and then we're going to have some global finalization aggregate that's going to put the local aggregates together. Now, in terms of actually doing a group by with this, we can use hashing or sorting. In previous slides, we saw a sort-based group by, and we know how to do parallel sorting. So the group by we learned in the iterator slides is sufficient over a parallel sort to give us parallel group by. But we can also do parallel group by in one shot using a hash-based group by. So before we parallelize it, let's briefly go over hash-based group by. A naive scheme for hash-based group by does this. Locally on every node, we're going to do aggregation in a hash table. So in the hash table, we'll keep, for each group, the running ag so far. So if we have select sum of price grouped by cart, then for each cart ID in our hash table, we'll keep the sum so far as we scan through the rows. Okay, and so that hash table of sums sits in memory. There's one sum for every grouping value, and that is the state of our aggregate on a local node. Then when we go to a global aggregation, what we're going to do is that each one of these local aggregates is going to be hashed based on some hash function HP on the grouping key, so that all of the partial aggregates for a particular group will end up on the same receiver node. And then that receiver node can compute the global aggregate for that group with key KI. So you've seen a naive scheme for parallel hashing for group by. And as an exercise, you should try to figure out how to get a parallel scheme like it that doesn't use naive hashing. It uses grace hashing. And this will be a two-pass algorithm, obviously, but it'll allow parallel hashing for group by to work without the data fitting in memory. So see if you can figure out how to do that. And usually you don't need to do this unless you have a large number of groups, because it's the group by tables that have to spill memory to require a two-pass grace hash. Similarly, if you didn't quite understand how to do the parallel sort-based scheme for group by, you should work that through as well. It's pretty much a pipeline of parallel sorting followed by group by.